Oh my gosh. Oh, I've just had a horrendous realization. Have I been on mute this whole time? No! Oh, I'm having such a techie rubbish week. Ah! Oh man. Have I been muted this whole time? Ah! Ah! I could scream at technology sometimes. It's not technology's fault, is it? I didn't check. That's my bad. Is anyone still there? Is anyone still trying to watch? Oh my gosh, Ruth. Oh my gosh. Sometimes I find myself remarkably irritating. But I also need to be kind to myself and say it doesn't matter. It's not a big deal. In the long run, nothing bad has happened. Okay. So, has anyone actually managed to stay with me? Because probably not. Probably you're like, oh my gosh, I can't hear anything. What's going on? This is impossible. If you are here, wow. Wow, you've done well. Wow. Okay, I'm going to put a quick message on Facebook just to say I'm not silent anymore. And then, right. What? Yeah, and then I'll go back to this. Oh man, alive. What? We're attempting to watch your live on YouTube. We can't hear the sound. Okay, Caroline, you've seen that. Thank you, Caroline. I am not mute anymore. Sorry. Oops, guys. Oh, I can't believe I've done that. Right, okay, let me go. I've replied to you, Caroline. I didn't mean to. So sorry. Promise I am not mute now. Oops. Okay, right, let's try this again. So, let's get rid of all that. And let's start from the beginning. Hello, Maths Mob! For anyone that's managed to cling on, I am so sorry about that. I massively messed up. Thank you for persevering. Thank you hugely for those people that did persevere and letting me know. So 64 is an amazing number. It's nothing to do with Christmas. I'm basically plan super far in advance because I love just diving into maths for like a couple of days and really like nitty gritty about it. So I wasn't thinking about maths when I planned this. So to make up for it, I've done sparkles on my face. I hope that's a bit Christmassy. And then after this, I'm taking a couple of weeks off to celebrate with my family and to have a bit of downtime and stuff like that. And then I'll be back in January. And I want to know what maths you want to find out about. So I was like, maybe it's good you didn't hear some of that because I suggested like awful things, not awful things, but like things that might blow my mind mathematically, like what's the maths in a roller coaster, for example. But you tell me things that you think it'd be interesting to find the maths behind, and I want to research it and then make it super accessible. So yeah, let me know. I'm going to put a vote up about that or something. So 64. I want to convince you 64 is an amazing number today. So start with 64. If you've not got a calculator, you can grab one. You can also do this without a calculator. This is the fourth time I've done this week. I've explained it really badly the first time, the other 3 times. So this time I'm going to do it well. We start with 64. You're going to divide it by 2. The first time you divide it by 2, you get the answer 32. So you then make a note of that answer. You don't have to make a note of these if you don't want to. But I'm going to be talking about these numbers and how many times you do this and things like that. It might be helpful to have a note of it because it's quite hard to remember. Then I want you to divide by 2 again. And I want you to keep dividing by 2 until you get to a point where you get a decimal or a fraction. I do not want decimals or fractions. No decimals or fractions, please. I only want until you've got to the last whole number. Now, I was drinking coffee before because my not New Year's resolution, as in I'm starting from today because I think you just have to start when you think about it, is to actually shut up long enough for you to do some maths and just be quiet so you can have some thinking time. So I'm going to do that now. I'm going to be quiet whilst you guys have some thinking time about this and actually have a go at doing this. Okay, so I'm going to do that now. And I'm also going to message on Facebook again to say about being silent. Okay, how are we doing with that? So this is a point where I think I can talk again. So hopefully you have 32 and got 16. And then halved 16 or divided by 2. And you got 8. And then halved 8 and you got 4. And then halved 4 and you got 2. And then halved 2 and you got to 1. Hopefully that is what happened when you did this. So I just need to make sure I can see myself again on YouTube. Is it showing me it? Is it going to catch up to me being live? Okay. No, it's not doing. So hopefully this is the pattern you got, similar to this one. So I'm going to angle this down a little bit so you can see it. So I want to know, like, how many times we divided by 2 for 64, because then we're going to look at going backwards. So for 64, to get to this 1 here, because if we divide 1 by 2, we're going to get to a decimal. We're going to go into fractions or decimals. So we don't want to go any further than that. So technically, we could take 64 and we could divide it by 2. 1, 2, 3, 4, 5, 6 times. So we could divide 64 by 2 6 times. If we reverse that, if we go the other way and start multiplying by 2 instead. So if we do 2 times by itself 6 times. So 2 times by 2 times by 2 times by 2, 1, 2, 3, 4, 5. Oh my gosh, I'm writing behind myself. Times by itself 6 times. If we do that and put that into our calculator, we're going to end up with, I hope, try this now, put it into your calculator. 2 times 2 times 2 times 2 times 2 times 2. So that's 6 2s. Hopefully, you should end up with 64. So what I want to know then is, if we do 2 times 2 times 2 and we do it 5 times, what are we going to end up with? And if we do it 4 times, what are we going to end up with? And if we do it 3 times, what are we going to end up with? And 2 times? And 1 time? And what if we do it no times? What if we just do it no times? What will we end up with? That is what I want to know. Okay, so, oh gosh, that went really close to my face, didn't it? I love a good close up. Amazing. What will all of those give you? So when we did it 6 times, we got 64. Do it 5 times. See what you get. Do it 4 times. Do it 3 times. Do it 2 times. Do it 1 time. What do you think will happen for no times? It's an interesting one. It's an interesting one to think about. Have a go. I'm going to give you a second on your calculators to have a go at that and see what comes up. And then we'll see how this makes 64 pretty awesome. In fact, it makes quite a few numbers pretty awesome. So what numbers did you get? Did you get, hopefully, 32? Did you get 16? Did you get 8? Did you get 4? And did you get 2? Did you get those numbers? The numbers in this pattern here, 64, 32, 16, 8, 4, 2. What do you think is going to come next when we do it no times? What's going on here? What have we been doing to get from one to the other? Did you spot a pattern between these numbers? Well, on this side, we were dividing by 2. So we were halving each time. So we had to half 64 to get 32. We had to half 16 to get 8. We had to half 8 to get 4. We had to half 4 to get 2. And then when we got to 2, we had to keep going. We had to half 2 to get 1. So actually here, we've got 1. And that's a really, really bizarre kind of result. But it links. And it links to something. These are all called powers of 2. We can write these as 2, which is a big number, with this little number, which is called an exponent. And this little number is a power. It's like 2 to the power of something. I'm going to show you now. I've got it on a PowerPoint. We're going to show you what that looks like now. And we can write all of these numbers, 64, 32, 16, 8, 4, 2, and 1, and more numbers, many more numbers, as 2 to the power of something. So let's have a look on here. We've got 64 on here already. So I've got 2 to the power of 6 is equal to 64 because I did 2 times 2 times 2 times 2 times 2 times 2. So I did 6 2's multiplied together to get 64. So I can write that as 2 to the power of 6. 6 is the exponent. You don't need to worry about the words so much. But we can do that for all those numbers. All those numbers we've just found. 64, 32, 16, 8, 4, 2, 1. They can all be written as the power of 2. So we've got 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 1, 2 to the power, 2 to the power of 2, 2 to the power of 1. And then for 1, it's 2 to the power of 0. And it seems counterintuitive that that's in that pattern, but it is. We're halving, so it has to be in that pattern. It's actually in all the patterns where you're looking at powers of numbers, because you end up with this thing where you divide a number by itself. And these numbers are really important for binary, which is what we use for coding and in computers. It's a code of on, off, and like it can be any pattern that we can use to communicate any number in the world. And I want to show you how we can do that now. So I'm going to get rid of the powers bit because that can be confusing. We're just going to keep the numbers we started with, 64, 32, and so on like that. So in binary, 64 would be written like this. So the green is a light that's on, the white is a light that's off. So it's on, off, 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 off. And to translate that into binary, 1 is on and all the zeros are off. So 1, on, off, 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 off. Like that. Okay. So we're going to do a little quiz now on writing numbers in binary. If you've got the worksheet, the printout, which I think I messed that up a bit this week because I think I did a copy and paste and ended up pasting over something else that I wanted to keep there, but I've not had a chance to rectify it since I realised, I'm afraid. But the quiz is on there. If you don't have it, you don't need it. You can do this on a scrap piece of paper. You can do it by shouting it out. You can do it on a whiteboard. I love whiteboards for maths, by the way. You can do it however you want. Or you can just listen and watch, whatever suits you. So 16. This is my next example. 16 in binary. I wouldn't need anything on the left here because those numbers are too big. So I would just start at the 16. And I need that one on. But everything else needs to be off. So it's on, off, 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 off. And I write that in binary as 1, 0, 0, 0, 0. On, off, 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 off. But we can make other numbers. So we can make, for example, 20. I don't need any of the numbers bigger than 16 because 32 is bigger than 20. See, those ones are no good again. But if I want to make 20, if I take 16 and I add 4 to it, I get 20. So I want 16 on, 8 off, 4 on, 2 and 1 both off. So I put that into binary as 1, 0, 1, 0, 0. On, off, off. So I can use these and combine these numbers in different ways to make any number that exists. And then I can communicate it just through these ones and zeros, ons and offs. So let's have a go at some. Let's have a go at some. So how would you communicate? How would you write 8 in binary? So you can either do it with the lights. So a green light for on and a blank light for off, or you could do it with the ones and zeros. Have a go. Have a go at 8. How would you write that as binary? So I get for 8 like this. It's on, off, off, off. So 1, 0, 0, 0. Did you get the same? What about 10? How would you do 10 in binary? So 10's not on there. So we're going to have to add some numbers together. We can't go bigger than 8 because 8 is after 8 it's going over 10. So we need 8 and we need to add on 2. So we're going to need on, off, which is 1, 0, 1, 0. How would we write 2 in binary? I used this in a joke on Facebook. I wasn't sure if people just thought I was really rubbish at maths or if they got the joke. It's a risk I was willing to take. How would we write 2 in binary? So hopefully you've got for this one something like this. On, off. Or 1, 0. It looks like 10. That's the joke. When you write 1, 0, it looks like 10. So if you say 1, 0 people, it looks like you're saying 10 people. But if you're talking in binary, you mean 2 people. What about 3? How would you write 3 in binary? How would you write 3 in binary? So I get on, which translates to 1, 1 in binary. It looks like 11, but it's not. It means 1, 1. It means on. What about 40? How would you create 40 in binary? Can't remember how many of these I did. I think there may be 1 or 2 more. Can't remember. Let's just run with it, shall we? At least you can hear me now. So for 40, we're going to need the 32 and the 8 because they add together to 40. So we need on, off, off, off. So 1, 0, 1, 0, 0, 0. Okay, yes, there we go. That was the last one. So being me and being my friends at university, I did maths at university. And I had friends that did maths at university, unsurprisingly. And we when we were 21, we didn't have a lot of money. So instead of doing birthday presents, we made these huge cakes. They were sometimes amazing and sometimes shocking. But there was one party where we didn't have 21 candles to put on the cake. And we didn't know what to do about it. And then we decided we would use binary to create 21 candles because you only need 5 candles to do 21 in binary in 2 different colours. Yeah, and then we told our friend there was 21 candles on a cake and she actually worked it out. And we thought that was really cool because, we're geeks. And but it was. So, how do you use the binary? If you've not got enough candles for your cake and you've got at least 2 different colour candles, this could be an option for you. I like to keep it real life. I like to give you practical uses for maths as well. So I think 64 is really cool because it's useful in binary, along with all those other numbers and many other numbers that relate to binary as well. So I think it's really cool. Though there's other reasons why 64 is really cool. And this is links to why I was getting frustrated with my kids because they were they've taken over cubes and created things that were quite cool, but they weren't cubes, which is what I wanted. So we'll start with this. I've shown you this pattern before. I think when we came to the number 4, I showed you this pattern. So we started off with 1 dot, and then we went to the next the next pattern, the next sequence, the next term. I'm not sure how to put it. The next picture. And we've got 4 dots there, but they're arranged in a really specific way. And then the next picture, we've got 9 dots there. And then we had 16 dots. And we looked at these and explored how they were all squares. So each of the pictures showed a square. And the squares were growing. And we looked at different ways that they could grow. And we've got a 1 by 1, 2 by 2, 3 by 3, and 4 by 4 square here. And if you continue that pattern, you can keep going and keep going. What you're creating is special numbers called square numbers. And we can find these numbers out by doing 1 times 1, which gives us 1, 2 times 2 gives us 4, 3 times 3 gives us 9, 4 times 4 gives us 16. And you're essentially finding the areas of these squares. So I'm going to show you something here. This is a square, and this one's got 64 dots in it. 64 is a square number. Now I'm going to leave that picture up for you. See if you can work out what number we have to square to get 64. What number do we have to square in order to get 64? So it might be helpful. I said I'd leave that picture up for you. Before that, I'll just show you something. I'll write some things down. So what do I mean by squaring? I'll just explain that again. So for the 1 dot, I did 1 times 1, which is 1 squared. And that gave me an area of 1. For the 4 dots, it's got a length of 2 and a width of 2. So I did 2 times 2, and that was 2 squared. So that's how I got 4. For the 3 dots pattern, so it was a width of 3 and a length of 3, and that gave me 9 dots, and that was 3 times 3, which is 3 squared. So I want to know for the 64 dot pattern, there's a number that I'm squaring to get 64. So I'm going to show you it again, see if you can work out what is the number that I'm squaring to get 64. I'll pop it on here. What's the number that I'm squaring in order to get 64? So you can look on your screen. I think this is the thing I forgot to put on the printout. I think I intended for you to have this picture to actually look at, and I totally forgot. I think I put it on and then I copied and pasted over it, which is annoying, frustrating, but I'm sure we can all work it out. We can all survive. What is the number that's squared to get 64? And you can count those dots if you want, or you could test it by doing something times something. What would you times together to get 64? Has anyone counted these dots? I didn't count all of them, but what I did was count the side. 1, 2, 3, 4, 5, 6, 7, 8. And just to check, I also counted like this side here. 1, 2, 3, 4, 5, 6, 7, 8. Good. They should be the same because in a square, you've got the same width and the same length. So if we do 8 times 8, and you can do that in your head or you can pop it in a calculator, 8 times 8 gives us 64. So 8 squared, it's 8 squared, 8 times 8 is 64. So 64 is not only really important in binary, it's also a square number. We can create a square out of it. But even better than that, we can create other things out of 64 as well. So this is what I wanted to show you that my kids pulled apart to make their amazing contraptions. Was we can take square numbers and we can actually do something else with them. We can grow them more. So if I wanted to take, for example, I'll show you with 2. Because it's probably the easiest one. I'll show you in a couple of different ways. Some people like physical things, some people like pictures. All is fine. Everything's good. So if I have a length 2, it means 2 blocks long, 2 centimeters long. It's a length of some form. I've got, it's 3D here, so it's not the best example, but you get the idea. I've got 2 blocks going along. So that's 2. Then if we do 2 times 2, I get a square. So I'm working out an area, 2 times 2, and that gave me 4. So I've gone from 1 dimension, just a length, to 2 dimensions, length and width. Now, if I do 2 times 2 times 2, I'm introducing a 3rd dimension. I'm creating a cube because we've got a length, a width, and a height. And all I've done is taken 2 of those cubes. I don't know which one I've done. There we go. I've taken 2 of those squares, sorry. So I had a square, it was 2 by 2 square, and I've created another one and stacked it on top. So it is also got a height of 2. But to do that, I actually needed quite a lot more cubes. I needed double the amount of cubes. So I started with 2, then I doubled it to get 4, and then I doubled it again, and I needed 8 to create the cube. And we can do that with other numbers as well. So for 3, this is where I'm having to do it on the job, so to speak, because my kids pulled everything apart. So I could do it with 3. I start with a length of 3, and then I want to create a square or an area. So I need to do 3 by 3, which takes us to our square number again, which was 9. So I end up with 3 lots of that length. And then I want to turn that into a cube. I need to introduce another dimension. So I'm going to go up 3 and create a cube. And that's going to give me 3 lots of these squares. So 3 lots of 9, which is 27. And if I can continue that pattern all the way up, and I didn't have 64 blocks left to do this. If I continue that pattern all the way up to a 4 by 4 one. So if I have a length, start with a length of 4, and then I do 4 times 4 to get a square. So I get the area 4. And then I do introduce another dimension. So that was length times width. Then if I do length times width times height and make this into a cube, so it's got a 3rd dimension, I end up getting, well, try it in your calculator. You might already have guessed. What is 4 times 4 times 4? So 4, we know the answer. 4 times 4 gives us 16. Is that what you said? Yeah, 16. And then 4 times 4 times 4, try that in your calculator. What does that give us? 64. What? So 64. Not only is it in binary, really, really important in binary, it's a square number. So you can create a square out of 64 blocks, dots, whatever. It's also a cube number. So you can create a perfect cube out of 64 blocks, dots, or multiplying it to find, in this case, the volume, because we're doing length times width times height. I did say to bring some cubes to try doing that, but because the whole muting thing, I decided to go a little bit quicker with this. So sorry if you had like your box ready. You can have a go afterwards at doing that. But yeah, so I'm hoping I've convinced you 64 is a pretty impressive number. It's not only essential to using computers, it's a square number and a cube. And there's not many numbers that are both square and cube. In fact, the only one I can think of off the top of my head is 1. 1 is a square number and a cube number as well. But there's not many of them out there. It's a super, super special number. That is the end of today's. I'm just checking I have covered everything. I have covered everything, even if it was a bit quicker than I'd hoped. Sorry, I can't stay too much longer because I'm due to go climbing with my husband and my kids, and it's not often we get to do stuff all together. So I'm quite excited about that. It's like our first holiday. Woohoo! But if you are enjoying Maths in Motion, even though I sometimes mute myself and have tech issues, and you want to keep like attending these lessons, please do consider supporting me if you can do that. At the moment, I can send you a maths mod memo, which is about the number 6. It's my first ever one, so it's little, but it's exciting for me, and I'll sign it because I think they'll be worth a fortune in the future. And I'll send some origami paper. I won't subject you to videos of me doing origami. They were awful. But you can definitely Google people doing really cool things with origami. I've made some suggestions for you and some stickers. There's the Math Mom Memo stickers. There's some to do with pie. And I can design those myself as well. I'll send you those through the post. And I'm currently working on a more exciting, even better, bigger Math Mom Memo full of like games and puzzles and things you can do at home. I'm going to try and link in some artwork as well on fractals. I love fractals. I'm a bit obsessed with them. So I'm working on that. And if you're already a member, it'll come to you first. And you can sign up on my stand store. So yeah, that's there. And after the summer, after the Christmas, I'm going to introduce some new sessions called Number Sense. Watch out for those too, because they could be really cool. And also vote on what you'd like to do. Oh my gosh, there were so many things. I can't believe I've remembered that many. There's probably more that I forgot. Have an amazing Christmas. I'm going to shut up and actually say thank you so much for joining me and goodbye for now. Oh, no, I'm not. I'm quickly going to see if anyone actually managed to stick with me. And so I can say hi on Facebook, because that would be awful if you actually did and then I forgot to say hi. That would be horrendous. I'm so sorry about muting myself. That was like utter dire. Okay. Caroline and Co. I ate till I was sick on the floor. Is that with 8 times 8? Okay. I'm not 100% sure. Is that what that means? I hope you actually weren't sick on the floor. I really hope you were. If you were, like, oh my gosh, get better soon. That would be awful. But I'm hoping it's to do with you 8. Oh, I've just got it. 8 times 8 equals 64. Sick on the floor. Oh, yeah, you weren't sick on the floor. It went with that really well. Yeah, okay, cool. That's awesome. Thank you for sticking with me, Caroline and Co. Thank you so much. Yeah, oh gosh, that is like probably my biggest disaster yet. I don't know. It's either that or totally like detaching my webcam and not being able to get it back on. One of the two. Yeah, I think it's only you guys that managed to stick through, but thank you. I really appreciate you being live. Hopefully other people will catch this on the recording and I can see that then. And I'll see you after Christmas, where I can't promise there'll be no more tech issues, but I'll try my best. Bye for now, guys. Bye for now.